I'm Gary Wagner, president of Ophir-Spiricon. We make laser measuring instruments. There are two major types of measurements one makes of a laser. The first being averaged or instantaneous power using a sensor and a meter. The second is spatial distribution of the power across the beam. Those are configured either using a camera-based system or a slit-based system. One asks me, why buy Ophir products versus the competition? It's easy for me to tell you that it's our technology. We spend more per revenue than any other laser measurement company in the business. Or I could tell you that it's our quality. We manufacture all of our products under the ISO system, and they are traceable to NIST standards. Or I could tell you it's reliability. Our products hardly ever fail. But in reality, it's really our people. With almost 30 years of experience in this business, our customer support and our sales engineers are there for you. They can help you solve your problem to your application. There are over 100 different heads and multiple configurations of both cameras and scanning slits. And the one that's best for you is the one that they can help you find. In this video, our sales engineers will teach you what you need to consider when choosing a beam profiling system. At the end, you'll be given an opportunity to contact them and further these discussions.
Oftentimes people don't realize how critical their laser beam profile actually is.
Understanding what the beam looks like, its size, its shape, its intensity.
What is your laser like? What are you trying to accomplish in either your lab or on your factory floor?
Each of the applications has requirements that the laser perform in a certain way.
And if you're using the laser as a tool, welding, drilling, scribing, the quality of your drill, your cut, is going to be a function of what your beam looks like and how well you can maintain that.
In many cases, you need to make a very small spot and know exactly how large that is.
And to give context for how that instrument will help their research or their manufacturing activity.
You want to see exactly what is hitting the sample and optimize that to what you're doing.
A common misconception has been that lasers never change, and we know that's not true.
A laser beam's sort of like a light bulb. Over time it will degrade.
And quite a few of them are very surprised when they see the beam profile for the first time because they have expected it to be completely different.
All of those things require that you measure that laser, and you look at that laser beam shape, the beam profile as we call it, or the spatial irradiance, which provides you with the information you need to create the laser beam that works for your application.
You're actually able to see what's happening while you're making adjustments in your system.
You'd like to know that the day you get your laser and 2 years later that it's still performing the same way.
They're wasting a lot of time and money because they're not qualifying their lasers when they come in.
Reduce your downtime, predetermine maintenance periods, throughput.
So we are then secure that the application is going well.
Little nuances that you can't get looking at a website. And that's what I'm there for, to help answer those tough questions that you can't quite get the answer to.
So you got to design the optimal tool for your application.
We try to interact with the customer to try to understand what their goals are.
There are several aspects in selecting the proper beam profiler.
4 things you need to look at are wavelength,
energy or power,
the size of your beam, how large is it?
And is the beam pulsed or continuous, and if it's pulsed, what the rep rate is.
If we know those 4 aspects of the laser, we can then determine the best profiling equipment for that application. There's a variety of lasers from UV to terahertz.
Different wavelengths are designed for different things.
Different sensors have a different response depending on the wavelength.
If you have a mid-infrared laser, you would have one type of detector. If you have an ultraviolet laser, you would have a different type of detector.
Wavelength then determines what sort of detectors we're going to use.
For power and energy measurement, because of the way the light is absorbed onto the sensor, you might have a flat detector that's a flat spectral response, but slower rep rate capability, or you might have a higher rep rate sensor and they're wavelength sensitive.
For a camera-based system, it's going to depend on what camera you can use, whether it's a silicon or an InGas or a Pyrocam. They have specific wavelength ranges in which they're most effective. So if you have something that's in the visible, you'd want to use a silicon. It has the best resolution, most sensitivity. If you're running out at telecom wavelengths 1550, an InGas or a phosphor-coated camera will work. A silicon will not. Or you could use a Pyrocam. If you're looking at longer wavelengths, like many of the defense applications, you're out 2+ microns, you want to use the Pyrocam because it has sensitivity all the way out into terahertz range.
With the nanoscan, we have a germanium detector which works from about 800 nanometers up to about 1800 nanometers. And that's right in the wavelength range for the telecom industry.
So it's very important to match up the application of the wavelength to the cameras.
A laser is basically photonic energy. It can tear things up. And in fact, it's used to weld, it's used to ablate, it's used to cut things.
The power is important to know for several reasons. One, do I have enough power to use a pyro detector? Do I have to use a silicon or germanium detector?
Typically cameras are very sensitive, so you'll want to take into account the power. Usually you have to reduce. You'll pick off a small portion of the beam and then you'll sample that, take that into the camera system, add additional attenuation typically so that you don't destroy the camera.
And if you have a high power in a very tiny space, that's the size of your laser. If we put too much power in a tiny space and you stick it directly on your sensor, you're going to blow a hole in it.
Do you need to attenuate your beam or not? And what sort of attenuation do you need? That also factors in with the wavelength because different types of attenuation schemes are only applicable to different types of lasers and wavelengths.
Knowing the beam power and how to attenuate it is a critical aspect of accurate beam profiling measurements.
A system for a 5 milliwatt laser is completely different to a system for a 100 watt laser, and this is completely different to a 1 kilowatt laser.
The options available from Ophir-Spiricon and Photon allow us to deal with a wide range of powers.
Spot size will help you determine whether you need to add any additional optics or whether you can take the beam directly onto the sensor.
Systems out of the box have specific beam size designs.
And you need to illuminate at least a certain number of pixels to get an accurate reading.
If you overfill the sensor, the detector, if your beam is much, much larger than that, then you're not going to get a proper profile. It doesn't matter what you do. You're just going to overfill it and you're just going to see a solid thing. You're not going to get the edges. You're not going to get the information outside that you absolutely have to have.
The beam is large. Sometimes we need to use some sort of beam reducing optics, or that also dictates perhaps a scanning solution that has a large enough aperture.
If you're using a laser and you're trying to look at a focus spot, it would be one type of profiler. If you have a very large beam diameter, you would either need relay optics or it would be a different type of profiler.
Developing and providing the necessary optics to either reduce the beam to get the beam onto the array or to expand the beam so the beam is large enough on the array will allow us to get accurate measurements.
If the beam is very small, I would say under 5 or under 50 microns perhaps, then one needs to use a scanning slit profiler. If it's larger than 50 microns, then CCD camera might work. If it's larger than 500 microns, then the Pyrocam will work. And in between that, in-gas cameras will work for beams about 100 microns or more. So the size of the beam that you want to measure is going to determine which kinds of profilers you can use.
In the laser industry, there's typically two kinds of lasers. There's pulse lasers and there's CW lasers.
CW beams are continuous wave, and what it is it just continuously runs the whole time. The pulse beam strikes it at certain frequencies.
Whether you have a continuous wave or a pulsed laser, and the repetition rate of your laser affects the decision on the type of beam profiler that you can use.
Cameras operate at typically a certain frame rate, and various cameras operate at high frame rates, others operate at very low frame rates. With a CW beam, it really doesn't matter. You can use any camera we've got, keeping in mind the other factors of the criteria needed. However, in a pulse laser, you have high energy levels for each pulse, and it's necessary then to be able to synchronize the camera with the laser itself.
Pulse beams are best measured with CCD, especially at lower rep rates. The lower the rep rate, typically the CCD is the better solution.
And if it's less than a kilohertz, then basically I'm looking at a camera system.
And so you can have Q switch, which are very, very fast, high power, high energy. You can have femtosecond pulses, which are very, very, very short.
If it's pulsing at a fairly high rate in the kilohertz, then it's quite possible to use the scanning slit.
But we have to know up front what you're using so we can optimally design a system for you. We've got good selection. We can select the proper one to fit your exact application.
From soft X-ray to terahertz, nanowatts to kilowatts, less than a micron to 3 meters, Spiricon and photon beam profiling systems ensure success of every laser application, whether medical, military, industrial, or scientific. Call 866-755-5499 to discuss your laser application with a Spiricon sales engineer. Or visit us on the web. Ophir-Spiricon, the true measure of laser performance.